Alright, now we're looking at the t-test for independent samples, and we'll just go ahead and read this. Recently, the instructor read a hammer and nail article on the method of hammering nails into wood. He decided to perform the quasi-experimental research study using a variation of the two-group post-test only in the randomized experiment. Since students already enrolled in the course, they are randomly placed into a control group or the treatment group. The control group students will not learn the new method, the hammer will nails in the wood using the technique from the pre-test. And again, the null predicts no statistical significance between the two groups. And just as when we do research, the null hypothesis usually means there is no change, there's no difference. The alternative is kind of our investigative point. So since there are only 2 students in the class, and the instructor randomly assigns 5 students to the control group and 5 to the treatment group. The method B group listen to the instructions, allow to practice. In another room, the control group, having practiced hammering nails to wood after method B instruction, 10 students receive 10 nails, and they hammer away. After the test, they count the number of nails hammered into the wood without bending. And this is the comparison between the two groups. Now, just estimating the raw data, he believes that there will not be statistical difference between the two groups. And just to be sure, we'll do a 2-test sample, assuming equal variance. Now, alpha is 5%. What does that mean? That means that it relates to the 95% confidence level. So in statistical tests, when we say we want to do 95% confidence, that's the standard. That means alpha equals 0.05. So whenever you're looking at confidence levels and you want to find out the alpha for that confidence level, you just go 1 minus the confidence level. So in this case, it's 1 minus 0.95, which is how they got at 5% for this. So after performing the calculation, they came with their following output: the mean of the two groups, the variance of the two groups, the observations, which is the sample size, pooled variance, hypothesis mean is 0, degrees of freedom is 8. So we're going to go down here. So the mean was 5.6 for A and 5 for B. Not much. However, he compares the two critical values. So 2.3 and 0.73 right here. These are critical values for each. Since the t-stat score is less than the t-critical score, so what does that mean? Since this score is less than 2.3, see the test statistic, that's one in our Excel output, that's the t-stat. This is our test statistic. Our test statistic and stats we will use to kind of reject or accept the null hypothesis usually. So we're comparing it to the two. So since that it is less than the critical score, there is no statistical nail difference between the two methods. So, and you could say the same. So some of this information we don't use necessarily because it doesn't apply as much. It's just a standard output for Excel. In our case, we're looking at 2 samples. That's why we're looking at the 2 tails right here, t-critical, 2 tail. And we're looking at the test statistic. So if this was larger than the 2.3, then then we would say that there is statistical significance difference between the two methods. So that's kind of a rundown of this quick example. I hope this helps, and just let me know if you have any other questions.